Yesterday, we learned about how DNA is copied and how it's translated into amino acids that make proteins. Today, we're going to talk about what happens when there are mistakes made in that DNA replication or copying. Now, these mistakes are super rare, but when you think about how much DNA we have in each of our cells, we have billions of base pairs. The chances of just one of those having a mistake, that actually makes it pretty common. So when you think of mutations or when you think of people who are mutants, you probably first think about superheroes, hideous beasts, and of course, Teenage Mutant Ninja Turtles. However, mutations are actually pretty common considering that most of you have probably had one or two mutations occur to your DNA already in your lifetime. And most mutations are not a big deal. So let's first look at three kinds of mistakes that can happen. There's actually many kinds of mistakes, but these are just three basic kinds. Now, one example of a type of mutation that can occur is called deletion. And that is when one nucleotide is removed, just like the delete key on your keyboard will delete or remove letters. So in this case, you can see that imagine you start with it where it says A, G, T here. So it didn't really look the way I was hoping because this is converted on to explain everything. And just imagine though that one of these is removed. Imagine that T is removed and all you're left with is A, G, C, T, A. And then imagine that these just kind of ignore those for now. So just imagine that you pull out one of those nucleotides. That's a deletion. And you will need to write this in your notes too, so make sure you're writing that in. Now, another kind is the opposite of that, is called insertion. And this is where one nucleotide is added. Now, in this case, again, just ignore this part right here because it got kind of messed up. But let's say you start with A, G, T here, and then you insert another T. So that would end up with A, G, T, T to start with. So that's a case where you have this T here added in where it did not belong. Now, another way you can have a mistake in your DNA is substitution. And its name would probably suggest to you that one nucleotide is replaced. So in this case, imagine you start with a T here, but then that is replaced with an A. So let's move. So now let's look at these different kinds of mutations that can occur. So you have the original DNA, which is here. This is how it started, right? And then here you have deletion, here you have insertion, and here you have substitution. Now, which one do you think is going to be least damaging? I'll give you a second to think about that. Okay, now if you said that substitution is the least damaging, you would be correct. And that is because if you look at the triplets, now take a look here, you've got AGT. Now, this triplet is, it's wrong. This triplet is correct, so that's good. And this triplet is wrong. So far, insertion is the best because we don't want mutations to occur generally. Okay, so mutations are a bad thing. So far, insertion is the best in this case. Now let's look at the next one, the next triplet, because the triplets are really what matter, right? The triplets are what make our amino acids form into proteins. So here you've got the next one, which is CTA. So let me circle that. And this one, no, that's not CTA. That one's wrong. And this one on substitution is right. Now GTC, wrong. GTC is fine. ACC, ACC. TAG, TAG, those are right. These are all wrong. When you have a deletion or insertion, that can mess up all of your DNA from there on out. So in this case, substitution has only one triplet that's wrong. But these four stay intact. Whereas the others, deletion and insertion, you have a whole chain of triplets that are wrong. So, three things can happen after a mutation occurs. So what happens if your DNA does change somehow? What can happen? Well, the most common thing is nothing. You probably don't notice it. So like I said earlier, we've probably all had one or maybe two mutations occur in our DNA in our lifetimes. Actually, for you, it's less, but for me, I've probably had more than you because I've been around for a longer time. There's been more copying of my DNA. There's been more chance for it to mutate. But for the most part, we don't notice most of these mutations. And that's the most common effect, is where it's somehow lost in the jumble of everything because it's just one base pair that's changed. Now, the next change is the next most common. It's a harmful change. And if you've ever heard of cancer or tumors, that is caused by mutations. And you see this little girl here? She unfortunately had a mutation in her cells that causes them to reproduce out of control, and it formed this giant tumor in her face. So that's what cancer or tumors are. It's usually when your cell has a mutation that makes it divide through mitosis out of control where it doesn't stop. And the cell takes over the body and can often cause someone to unfortunately become very sick and die. So that's why it's such a big deal, because this cancer, it takes over your DNA. Now, in the past, when people didn't live so long, just 100 years ago, most people lived only to be in their 30s or 40s. Cancer wasn't so common. Now, why is that? Well, it's because when you live only to your 30s or 40s, you have not really had much of a chance for your DNA to change a lot. But as we live longer, it gives more of a chance for our DNA to mutate. And the more it mutates, the more likely it is that something bad will happen. Now, by far the least common, is an improvement. Like, can you get superpowers? No. Well, you can technically, but it's very, very unlikely. It's like if you're typing a paper and you make a mistake or a typo, what are the chances that that typo will make your paper better? When's the last time you made a typo that actually improved your paper? It's very unlikely because mistakes in your DNA are not going to help you generally. Now, every once in a while, maybe 1 in a million or a billion chance, this mutation might be helpful. And that's very important for something we're going to learn about later. But so keep that in mind that mutations are rarely helpful, but sometimes they are helpful. And those rare occasions, are very, very important. So, here's some vocabulary. The first word, or really the only word, is a mutagen, and this is something that makes mutations more likely. Now, there are a few things in the environment that can penetrate into your cells and make it more likely that the DNA is going to become mutated. And these are called mutagens. Now, one important thing to remember is that mutagens are not always man-made. So, for example, when people talk about chemicals or natural things, a lot of natural things cause a lot of cancer. So, for instance, sunlight is natural, but sunlight is a huge cancer causer. So, here are some examples of mutagens, like smoking, for instance, and fried foods, too much sunlight, radiation, eating too much red meat, all sorts of pollution and viruses. Now, this is just a short list of things that can cause problems. Smoking, there's about 1 million reasons why you shouldn't smoke, but one of the biggest reasons is that when those chemicals are exposed to your lungs, they get into your lung cells and they change the DNA inside your lung cells and cause lung cancer. Same with sunlight. Sunlight, if you should wear sunscreen when you're outside too much, right? Well, if you don't wear sunscreen, the UV light from the sun can penetrate into your skin cells and change the DNA of your skin cells. And that will cause things to grow on your skin. And if you have any abnormal growths on your skin, you have to get them checked out because those might be cells that had DNA mutations. So red meat can also cause mutations. You generally want to move away from pollution. Okay, and there are even some viruses. So many of you have probably recently gotten a vaccine called the HPV vaccine. That is to prevent a virus that can cause cervical cancer. Now, this is all kind of bad news, right? But there's some good news too. There's things you could do to prevent mutations as well. There are things you could do to protect your DNA. And one way to think about it is, well, avoid all of these things. Doesn't mean that you can't eat fried foods ever, but avoid it. Don't eat too much of it. And don't stay out of the sun all the time. Just limit your exposure to the sun. So here are ways that you can prevent mutations. And one really well-known way is to exercise. Another is to eat fresh fruits and vegetables, especially colorful ones. That's kind of a rule of thumb, is that when you eat colorful foods. Use sunblock when you're outside. Live far away from pollution. So if you know an area has a lot of factories or a lot of dumping in water, you don't want to live around there. You have to make the choice to not live around there. Now, that could be a problem, however, because there are other economic realities that we have to face, like finding a job and moving to out of areas that we might not want to live in. It's difficult, but if you can, live far away from pollution. And of course, do not smoke, because there are about 1 billion reasons why you shouldn't ever do that. This concludes today's slideshow. So now you need to fill out the rest of your note sheet, and there is another video on the Haiku website that you can check out if you have extra time.